Hi guys, on Friday we learned that energy is conserved, just like the water in this glass. I can pour the water from this glass into the other glass, but the total amount of water doesn't change. It's the same level of water as there was in this original glass. Now I'm going to pour it back into this other glass. Oops, looks like I'm spilling some. Oops, spilled even more. Okay. Well, the water level in this glass is not as high as the water level that was in this glass before I poured it, all right? But does that mean that the total amount of water was not conserved? No. There's still the same total amount of water in this area right here, all right? It's just in different places. Some of the water is on this plastic little tray that I have here, okay? So the total amount of water is still here. It's just in different places. And this is the same thing that happens when energy is converted into heat, or when energy is converted to sound, or when it's converted to light, all right? Some of the original energy is lost to this conversion. Now I put quotes around lost because energy is really not lost. It's just transferred somewhere else, all right? Some of this energy is being transferred somewhere else. In this case, some of this water was transferred to this tray, all right? Not all of it made it in this cup. Or like with a roller coaster, all right? So when you're at the very first hill on a roller coaster, you have the maximum amount of potential energy. It's the highest hill in the roller coaster, all right? And you roll down, and that potential energy is converted to kinetic energy, the energy of motion. But some of that original potential energy that's converted to the kinetic energy is lost in the form of heat energy, okay? So as the roller coaster rolls down the hill, its wheels heat up as a result of friction, okay? So some of this energy is being transferred to the tracks and to the wheels as heat energy, okay? Now, since this car now has less kinetic energy, it has less energy than it originally started with, than what the potential energy that it was converted to was, it is going to have a harder time making it up this second hill, okay? So that's why roller coasters, if they're just relying solely on gravitational potential energy and kinetic energy alone, that's why roller coasters have to have a smaller second hill, because the roller coaster, has less energy as it approaches the second hill. All right. The total amount of energy, if you look at the whole system of everything, the total amount of energy is not lost. The amount of energy that we started out with at the top of the hill has been converted to heat. It's been converted to kinetic energy, but it's all still there. All right. None of it has been destroyed. It's all still there. You just need to know where to find it. Okay? So yeah, that's the law of conservation of energy. Energy cannot be created or destroyed. It can only be transformed into different forms of energy. In this case, I am taking, let's say, potential energy, and I'm converting it to kinetic energy. Okay? I've converted this energy, but the overall amount of energy has not changed, all right? So that is the law of conservation of energy.